Hello friend, once again welcome on board. Hope you are doing well, and today I am going to share you information about the reverse bleed system of CFM LEAP engine. Why this came into the market, what is the reason behind this, what is the concept behind this, what is the use of this, we'll discuss through this video. Please watch this video till in for better understanding about reverse bleed system, and please don't forget to hit the like and subscribe button on my YouTube channel. Link is already mentioned on the screen. So let's start with reverse bleed system of CFM LEAP engine. Before that, we'll know about what is the fuel nozzle using in the CFM LEAP engine, what type of fuel nozzle we are using. So this is your fuel nozzle, you can see the diagram. This is your fuel nozzle. CFM LEAP-1A utilize the advanced 3D printed additive manufactured TAPS 2 type fuel nozzle, which is twin annular pre-mixing swirler fuel nozzle with the complex internal structure that optimize the fuel air mixings to achieve 15% better fuel efficiency and lower emission. So with this fuel nozzle they got 50% better fuel efficiency and lower emission. This nozzle feature precision engineered orifice design for durability, so they have required maintenance to address potential corking. So additionally, the engine used ceramic metric composite CMC in the hot section specific turbine shroud, which are coated with an environmental barrier coating to protect against the high temperature water vapor. So you can see there is a ceramic coating. Ceramic coating basically silicon carbide fiber, silicon carbide matrix are lightweight and withstand with high temperature, allowing for the less cooling flow. So because it is subjected to high temperature, so they have used ceramic coating. So if you are coming further, the LEAP engine are experiencing significant fuel nozzle cooking, carbon buildup caused by the high shock back temperature during the engine shutdown, leading to restricted fuel flow and thrust issue. So this is the issue behind that. All these issues lead to an operational interruption. You can see the cooking events will be like this. This is just take an example of some other diagram. Buzzing on wing replacement of complete set of fuel nozzle, and AMM also revises for full set of nozzle replacement. Additional separate nozzle replacement also there, full set of nozzle additionally they have added. CFM on wing and analytics to trigger customer notification report for fuel nozzle replacement. So they are issuing CNR when the nozzle is required to replace when it is reaches to the limit. To mitigate this problem, reverse bleed system is being implemented in the LEAP engine and is comprised of reverse bleed blower, reverse bleed valve, check valve, and necessary ducting. This will automatically forces cooling air into the core after the shutdown to prevent the cooking. So this is your additional mod came. This is your blower fan, necessary ducting. Here you will find out the reverse bleed valve, and there is a check valve also for necessary ducting behind this. This system sucks air present into the thrust reversal cowling to be sent into the engine core through the HPC 10th stage. So they are using HPC 10th stage air after the engine shutdown, as long as 115 variable AC is available. GPU APU twin engine to avoid shock back temperature and reduce the cooking buildup. So this is taking 10th stage of air and till the GPU APU or twin engine any power is available. So we need this power to be available for this operation of reverse bleed system. Reverse bleed valve open at the engine shutdown to allow the bleed air from the blower to flow into the core area. The valve is activated by fuel pressure drop, hence remain closed during the engine operation. So this will be remain closed once engine is operation. So this is the diagram, you can see. We'll go further. Reverse bleed blower pull cooling air from under the cowl environmental, which act as a source of air to cool the fuel nozzle. The blower is powered with the new HJ8 harness electrical connection routed to existing EC blower power supply. They have used the additional harness for the separate connection for this. And there is a check valve, remain closed during the engine operation, act as a firewall. After engine shutdown, check valve flapper are opened due to blower air and gravity to allow the air flow to the core area. So we are using, see, you can see the blower fan air is going, reverse bleed valve will control, and check valve having concept due gravity it will open automatically and it will go to the core area. Cooling variable bleed valve and exhaust line set the check valve pressure drop after engine shutdown. Valve venting and cooling air protect to blower during the engine operation. So this will protect the blower. And transit bleed valve share the same bleed duct with RBS transit bleed valve actuator to be close position after the engine shutdown to allow the flow air from blower to the core. So once engine is shut down, this will be TBB will be closed condition. HPC stage 10 TBB seat compressor discharge nozzle port provide the access for the cooling air from the blower to enter into the core and flow around the fuel nozzle. So it will flow around the complete fuel nozzle area. Total 19 fuel nozzle are there. So electronic engine control recognize engine shutdown and automatically activates the RBS via aircraft engine interference unit for a maximum of 60 minutes and loss of electrical power until the next engine is start. So whole function is taken care by the EC, and there is a various modification required from the avionics side also. So with this reduced maintenance cost by preventing coking, the system significantly reduces the need for premature, expensive and time consumption of the fuel nozzle replacement. So on-wing maintenance reduced with this modification. So frequently change of the engine fuel nozzle is reduced. And good to know information is that whenever you are approaching the aircraft on arrival, if you are see some sound around the engine, means this engine is modified with reverse bleed system. If there is no sound, means this is unmodified engine. So this is the question asked to me in during my authorization. So this is good to know information about the whether reverse bleed is installed or not. You can, while approaching the aircraft, you can identify the things. So guys, hope you have enjoyed with this video. If you love this video, please hit the like and subscribe button for getting more video on Airbus 320 family.